All right, 9.6, guys, it's called solving right triangles. We're going to talk about some application to sine, cosine, tangent, using trigonometric ratios to solve real-world problems. And then at the end, we're going to talk about just solving a triangle, and I'll mention what that means, okay? Now, right here up at the top, it says angles of elevation and depression. Now, the biggest thing we need to understand is that those things are the same thing. Okay? They're the same thing. Now, it just depends whether you're looking up or whether you're looking down. Okay? So it says if you look up, you are measuring an angle of elevation. Okay? If you're looking down, that is an angle of depression. The biggest thing of all, I want you to write this in a star here. Say must be created by line of sight and horizontal. Maybe you want to circle that thing. I'll talk more about this in a second. It must be created between the line of sight where you're looking and a horizontal line. So here we go. Example 1 says the angle of elevation from a sailboat to the top of a 121-foot lighthouse on the shore measures 16 degrees. Guys, I think a great option is to draw a picture every single time. Doesn't have to be elaborate, but there's a sailboat. Here's the shore. Here's the lighthouse. Okay, I'm not a great artist by any means. Okay, in the line, or excuse me, the angle of elevation from here to the top of the lighthouse is how many degrees? 16 degrees. Okay, now how high is the lighthouse? Well, that's 121 feet. Okay, now, kind of going back to the line of sight and the horizontal, this angle is formed between the line of sight from the sailboat to the top of the lighthouse in the horizontal line. Okay, it asks us, how far is the sailboat from the lighthouse? Well, isn't this, which way, is it this one? Is it the hypotenuse or the adjacent one that we're trying to find? Adjacent. When I talk about how distance, how far away something is, it's always going to be a horizontal distance. Okay? So I'm going to put an X there. Hey, so we drew a picture, we read it, we drew a picture. Now essentially I have a right triangle. Now if you want to draw this separately, absolutely, do it. 16 degrees. 121, and there's X. So with respect to my angle of elevation, which two sides do I have, Chris?
Two sides, opposite and adjacent.
Opposite and adjacent, and what's that, Dawson? Sine, cosine, or tangent? That's fine, look at your notes. That's tangent. So I'm going to say the tangent of 16 degrees equals the opposite, which is 121 over X. And now I'm going to solve it. I'm going to solve it the exact same way. Nothing's changing. I'm going to multiply both sides by x. And those are going to go away. So I'm going to get x times the tangent of 16 degrees equals 121. And then I'm going to need to divide both sides by the tangent of 16 degrees. So in our calculators, let's see here, 121 divided by the tangent of 16. .98. 421.98 feet. So basically 422 feet away from the lighthouse. Any questions there? Okay, second one. It says you see a rock climber at a 32 degree elevation. Your eye level is 6 feet above the ground, and you are 1,000 feet from the base of the cliff. What is the approximate height of the rock climber from the ground? It's important to understand when they specify how far above the ground you are looking, we have to keep that in consideration. Because do you have eyes on your feet? No. Like my eye level, I'm 6'5", so it's like 6 feet 2 inches above the ground, right? Big difference between me looking up at, let's say, the clock from my eyes or from the floor. Would you guys agree there as far as the elevation? And so here it says that your eye level is 6 feet above the ground. So let's draw this picture. We see a rock climber. So someone's sitting down here on the ground, not sitting, but is on the ground, okay? And there's a rock climber up here. I'm just gonna, rock climber. They look like that on a rock wall. And so we are looking from my eyes. So my eyes to the rock climber. And then that's a 32 degree angle of elevation. Now we're going to make this again with the horizontal line. So here's my angle of elevation, that's 32 degrees. Again, that is between the line of sight in which I'm looking and the horizontal. It says that you are 1,000 feet away from the base of the cliff. So this would be 1,000. What is the approximate height of the rock climber from the ground? So this is going to be x. Now we need to understand something. X goes to where? Your eyeballs or the ground? What do you say, Alan? It goes to your eyes because that's where our horizontal is, but we need to find it from the ground. So in the end, what are we going to have to do? We're going to have to add 6 at the very, very end. There's other ways to do it. I could call this whole thing x minus 6. Do you guys agree with me there? Because now I'm going all the way to the ground, but to be accurate, I better minus 6. I don't like that near as much. I think it's better just to call it, hey, that's going to be x. Uh-oh. I lost my rock wall. Ooh. What if you're climbing a rock wall and it automatically disappeared? And we're going to have to add 6 in the end, okay? So guys, and I always think it's a good idea. I always draw a picture, and then I always simplify it with a triangle to get my stick people and all this other stuff off of there. So I've got 32 degrees right here. I've got x right there, and this is 1,000. So, with respect to 32, which two sides do I have there, Serena? Opposite and adjacent. Eric, is that sine, cosine, or tangent?
Tangent.
It is tangent. So the tangent of 32 degrees equals the opposite, which is x over 1,000. Now to solve, I'm going to multiply both sides by 1,000. And x is going to equal 1,000 times the tangent of 36. 1,000. 32, thank you, times the tangent of 30.
Can I get a big compass for what you have one?
Yeah, I think you're totally messing up my video. Okay, tangent, or 1,000 times the tangent of 32, and hit enter. What do we need to do to that? Add 6. Because I want the ground, and that's going to be 630.87. So 630.87. We're in feet. Questions there? Okay, example 3. An airplane pilot sights a life raft at a 26-degree angle of depression. Now, this is where people will make a mistake. So it's important that we're paying attention. So I've got an airplane. That's pretty good, isn't it? And he sights a life raft. What's that, guys? It's a life raft. You can't tell it's a life raft? That's a life raft. And so, let me do this first. This is the line of sight. Would you guys agree? Line of sight from the airplane to the life raft. Now, don't draw this. Here's what everyone's going to want to do. Hold on. Did I make my angle of depression between the line of sight and a horizontal line? No. It is between the line of sight and a vertical line. No matter how you set the problem up, you're going to get it wrong. Okay? It needs to be the line of sight and a horizontal line. So essentially, this, I think a better way to do it would be to set it up like this. And have that angle be right there. Now, one thing I want you guys to understand, if I were to do it this way and put the angle of elevation right there, I could do that as well. So when I said up there that they're the same thing, the angle of depression and the angle of elevation essentially are the exact same thing. It just depends whether you're looking up or you're looking down. Okay? So the angle of elevation, I could have done it either way. I could have set up my problem this way and said, hey, there we go. But knowing that where my angle has to go. All right? Or I could have set it this way and put the angle there. Okay, I'm going to do it this way just because it's a little bit different. But no, you guys can have the freedom. Every year on the test, out of maybe 100 geometry tests, probably have less than that, 70 geometry tests, I'll probably have 10 to 15 of them that will put this in the wrong spot. So the angle depression is 26 degrees. The airplane's altitude is 3 kilometers. Where do I put that? Joe?
On opposite side?
Yeah, right here. 3 kilometers. Yeah, because that and that are going to be the same. Okay, so the elevation, the altitude is going to be right there. And it says, what is the plane's horizontal distance from the raft? Is that here? Here or here? The top one, right? Horizontal distance, put an X right there. Opposite and adjacent, which is tangent again. Guys, you'll see a lot of tangents. Why? Well, in real life situations, it's hard to measure the hypotenuse. We can figure out altitudes, we can figure out horizontal distances. Hypotenuses aren't as easy to calculate. So tangent of 26 degrees equals the opposite, which is 3 over x. I need to multiply both sides by x. X times the tangent of 26 equals 3. And then I need to divide both sides by the tangent of 26. X equals 3 divided by the tangent of 26. .15. What's our label? Kilometers. Any questions there? Okay, example 4, this kind of just reiterates this idea. We need to find x. A couple ways to do this, but would you guys agree with me that that one and that one are parallel? So this angle of depression is this angle of elevation. So now I can solve it that way. And again, we're going to have our hypotenuse here. So I'm going to have my opposite in my hypotenuse. So that would be sine. So the sine of 27 degrees equals the opposite, which is x, over the hypotenuse, which is 580. I need to solve for x, so I'm going to multiply both sides by 580. So 580 times the sine of 27, 263.31. 263.31 yards. I'm going to skip example 4. Okay, much of the same. Draw a picture, figure out what they're missing or what we're trying to find, and then go from there. Example 5. This is the next idea. Solving right triangles. Guys, the word solving or triangle, that means find all the angles and sides. It says, hey, solve that triangle. I want to find all the angles and I want to find all of the sides. So this is round to the nearest tenth. I like hundredth. We're going to do hundredth. Okay, so if I look here, I need to find everything. Now, I think the best thing to do, okay, is to have a little answer key here to put all my answers nice and neat and organized together. Instead of having them hodgepodged all over the place, we're going to put our answers all in one neat place. Now, I know what that's 90. I know that's 25. Can I find my third angle? Absolutely. How are we going to do that? 180 minus the other two? Or you could say 90 minus 25. What's G? What is it? Isn't that 65? 65 degrees. Okay. Angle G. So I don't know if I've talked about this. Big letters represent angles. Lowercase represents sides. So this is G, lowercase g, because it is across from angle G. Does that make sense? So angle G is 65. Okay, so I have all three of my angles now. Now we need to find my two sides. So I'm going to find G, and then I'm going to find H. So if I look at G, with respect to this angle, G is my, which side there, Cam? Adjacent, and 13 is my hypotenuse. Adjacent and hypotenuse is cosine. So the cosine of 25 degrees equals the adjacent G over the hypotenuse 13. Multiply, and again, we're doing the same stuff, guys. Same exact stuff, multiply by 13 on both sides. So G is going to equal 13 times the cosine of 25. What did we get there, Allie?
11.78.
11.78. Okay, and then lastly, I want you guys to know that we do, so this is 11.78. Can I use my the Pythagorean theorem now? I could, if we wanted to, use the Pythagorean theorem because I have two sides, right, of a right triangle. I can surely do that. But why not just use sine, cosine, tangent again? Joe?
Didn't we round so the Pythagorean theorem wouldn't be that accurate?
Yeah, we rounded. I can't, guys, don't get me wrong. When I say we round, and it's not going to throw the answer off like it's going to be wrong. Does that make sense? If we did the Pythagorean theorem with 11.78, we're going to be really darn close. We're going to be really close. So close it'll be right. But I try to avoid that. Does that make sense? Now you may go over to Mr. Juffer, and he may not have an issue with that at all. So yeah, we could do either way. I'm going to do sine, cosine, tangent again. So if I look at this angle, this is my opposite and that's my hypotenuse, so I believe that's sine. So the sine of 25 degrees equals the opposite, which is h, over the hypotenuse, which is 13. And then I'm going to multiply by 13 on both sides, and h is going to equal 5.49. So now I have all my answers in one spot rather than trying to hunt for them. Sydney, question?
How come we don't use the other angle?
It's a great question because we didn't need to. Yeah, we didn't need to. I could do everything right here with one angle. If you wanted to, and call this 65, and you would have gotten the same answer as doing it with the other angle.
Or would you have to use 65 for both of them?
Say that again?
Like, would you have to use 65 for both sine and
Well, so I just want you guys to know that if I use 65, now it kind of changes my problem, because now, like, let's say if I use this angle, angle G, which is 65, and I find G, that's going to be my opposite over hypotenuse. Now that's the sine. Does that make sense? But you could use either one, depending on how you do it. Either one. Now this one's a little different. I don't have any angles. The only angle I know is 90. Okay. So what I'm trying to find here is I'm trying to find side C. I'm trying to find angle B. Maybe I can do that too. Angle B and angle A. Those are what I'm trying to find. Now, could I do the Pythagorean theorem? Sure, I could, if you really wanted to. I'm not going to do that. But you certainly could. Now, let's find an angle first. Let's pick that angle. I'm going to pick angle B. Could I have picked angle A? Absolutely. Now, with respect to this angle, if I'm trying to find C, I could go about this a couple, excuse me, we can't find C until I know an angle. Now, with respect to this angle, if I pick those two sides, because those are the ones that I know, opposite and adjacent. So that's the tangent. So the tangent of B equals the opposite, which is 2, over the adjacent, which is 3. Now again, how do I find an angle when I know the ratio? Second tangent, we're going to call that tangent inverse. So tangent inverse of 2 over 3 equals B, and angle B equals 30 what?
33.693.
So 69, 33.69. So that's an angle. We just found an angle, right, Austin? So we're going to round to 2. If you find a side or an angle, round to 2. Talk about that later. Now, if I know one angle, then I certainly know the other, right?
Yeah.
Take 90, because these two angles have to be 90, because that one's 90. 90 minus 33.69. Oh, what's that get you? 60, 50? 56.31 degrees. Okay, so now I know this angle is 33.69, okay, and now I need to find C. So with respect to this angle that I know, you can use either 3 or 2. I'm going to use the opposite side. I don't know why. If you want to use the adjacent side, eat your heart out. Opposite 2 over hypotenuse. Opposite over hypotenuse is sine. So the sine of 33.69 equals the opposite, which is 2 over the hypotenuse, C. Multiply both sides by C. So I'm going to get C times the sine of 33.69 equals 2. Then divide both sides by the sine of 33.69. So 2 divided by the sine of 33.69. 3.61. 3.61.